Hello, this is Dr. Mode, and this video is going to be about the Chapter 14 review assignment. Let's get started. The scripture verse that I want you guys to focus on for today is Romans chapter 14, verse 21. It goes like this: "It is good not to eat meat or drink wine or do anything that causes your brother to stumble." So what I want you to keep in mind here is that, we're experiencing a lot of crazy things in the world and people are making lots of decisions. Some of those decisions may seem strange, like buying 500 rolls of toilet paper. But what we're called to do as Christians is we are called to love our brother. That brother may be a weaker brother and weaker in his faith or her faith in how they understand things, and what we're called to do is not to find anything we can to tear them down or criticize their choices, but we should be very kind to them and considerate, and we should use any opportunity to edify our neighbor. So again, this is a reminder to love your neighbor at all times, even in these crazy times that we're in right now. So remember, there are much more important things out there to worry about, to talk about, than what we might view as poor choices that people make during this time. So use this as an opportunity to advance God's kingdom, to evangelize somebody, not to make fun of somebody. Remember the first catechism question in the Westminster Catechism says, "What is the chief end of man?" And remember, this is asking, well, what's the purpose of life? What should our focus constantly be? And the answer is to glorify God and enjoy Him forever. Here is a list of vocabulary from chapter 14 that you guys need to be familiar with. I'm sure that you remember most of these. If you don't, then please go to the textbook and look them up. Again, chapter 14. This question says, determine the molarity of a solution containing 25.8 grams of calcium chloride diluted to 5.2 liters with water. So what you need to remember here is that molarity is moles per liter, and we've been given grams and liters. So first of all, that grams needs to be converted to moles. So to do this, we need the molar mass of calcium chloride. Here it is right here. It's almost 111 grams per mole. And what we're going to do is we are going to take the number given, 25.8 grams. We're going to divide it by the 110.9838 grams per mole, and that is going to give us the fact that we have 0.232 moles of calcium chloride. Now, again, what we're looking for is moles per liter, and we have both of those now since we have moles. So all we're going to do is divide those, take the 0.232 moles, divide it by 5.2 liters, and we're going to have our answer in molarity. Now this says, what is the molality of a solution of 178 grams of beryllium nitrate in 1,455 grams of water? So you got to remember, molality is moles per kilogram, okay? Moles of solute per kilogram of solvent. So that 178 grams needs to be converted to moles. So what we can do is we can figure out what the formula is of beryllium nitrate, and we can find its molar mass to be about 133 grams per mole. We need to convert that 178 grams to moles by dividing by the molar mass to figure out that we have 1.34 moles of the solute. And then now what we need to do is we need to divide that by the number of kilograms of solvent. So we're going to have to convert the amount of water in grams to kilograms, move the decimal place over 3 places, and when we do that division, we can find that this corresponds to 0.921 molal. This is a question about definitions, and it is wanting to know if you understand what a solute is. So it says if glucose is dissolved in water, then what is the solute? Well, when you dissolve something in water, the thing you're dissolving is the solute, so the glucose here is the solute. Now this question wants to know if you understand what a solvent is. So whatever you're dissolving into, that's the solvent. So we were dissolving in water, so that means the water is the solvent. So when we have this combination of the two, where glucose is dissolved in water, what do we call that? Well, we call that a solution. So what are the units of molarity? Well, they are moles of solute divided by liters of solvent. What are the units of molality? Well, molality is moles of solute divided by kilograms of solvent. And as a review here, what are the units of molar mass? When we add up the different elements on the periodic table and figure out what a molecule or a compound weighs, what are the units there? Well, the units are grams per mole. So this question says, how much water needs to be added to 2.6 liters of 4 molar hydrochloric acid to dilute it to 0.125 molar? So a dilution requires the dilution formula, which is MV equals MV, M1V1 equals M2V2. And if we notice here, we're given an M and a V, the 4 and the 2.6, okay? And we're given another M, but we're not given a second V. So what we need to do is we need to solve for V2, and you can see that I've rewritten the formula here on the right to do so. So now what we have to do is plug into the right spots. So let's figure out what needs to go where. So the first molarity that we've been given, the first molarity is 4.0 molar, and it corresponds to a volume of 2.6 liters. And then the second molarity that we've been given is the 0.125 molar, and that leaves the unknown, which is V2. So now what we're going to do is we're going to plug that in to the formula. So we plug those in and do the calculation. We find that corresponds to 83.2 liters. And what we have to do is we have to pay attention to the question. It says how much water needs to be added. Well, this 83.2 liters is the total amount. It's the amount of the solution that has that 0.125 molar concentration. So it already had 2.6 liters before we started to add more water. So we need to find out how much was added, which corresponds to a subtraction problem here. We're going to subtract that 2 liters off from the total to find that the amount added was 80.6 liters. This question says, when sodium chloride dissolves, how do the water molecules arrange around the solvated sodium ion? So remember, I was showing you guys a picture from your book where it was talking about the process of dissolving an ionic compound like sodium chloride. And what happens? Well, what happens is the water molecules go in and they dig out the sodium and the chloride ions, but because water is polar, they arrange in a specific way. And there was a picture, here it is right here, this is the picture from your book, and the picture shows that we have the hydrated ions with the water molecules arranged. And what you'll notice is that they're arranged differently. This is asking about the solvated sodium ion. So you'll notice that the sodium ion is labeled in a gray or silver color. So if we look at the one that's been solvated in the very top middle, you can see that the water molecule is arranged around there such that the oxygen, the red, is facing towards the gray sodium ion. So the reason is because the sodium is positive, and water, because it's polar, part of it has a slightly negative charge and part of it has a slightly positive charge. So the negative charge is the oxygen part, and the slightly positive charge is the hydrogen. So you can see, since the sodium is positive, the hydrogens, which are positive, are facing away from that sodium ion. So what is it called when you shine a laser beam through a solution and you can see the beam? What is that effect called? Well, that effect is called the Tyndall effect. So when calculating the colligative properties, so freezing point depression or boiling point elevation, what should you do with that I value? What does that mean, that I? Well, what you do is you look at the compound. If it's an ionic compound, how many different ions are there? Okay. Or if it's a covalent compound, you look at it and you say, okay, well, it just dissolves as one unit, so I is going to be 1. So if we look at this, KCl, potassium chloride, that's an ionic compound, a metal with a nonmetal. So there's 1 potassium and 1 chloride ion, so I is going to end up being 2 for this system. Very similar problem, but now we're looking at methanol. What you'll notice about methanol is CH and O, carbon, hydrogen, and oxygen are all nonmetals. So this is a covalent compound. So when they dissolve, they do not separate into ions because it's not ionic, it's covalent. So it's going to dissolve as 1 unit, so I is going to be 1. Okay, so similar question here. Now we have calcium chloride. You'll notice that calcium's a metal, chloride's a nonmetal. It's an ionic compound, and when it dissolves, this one is going to have 3 ions. It's going to have a calcium that's +2 and 2 chloride ions that are -1. So I, in this case, is going to be 3. Okay, now we're looking at tungsten 6 fluoride. So tungsten 6 fluoride is an ionic compound, Tungsten's a metal, fluoride's a nonmetal. So when it dissolves, the tungsten is going to be a +6 ion, and you're going to have 6 negatively charged, -1 charge fluoride ions, and that's going to result in an I of 7. So you add the 6 fluorides to the 1 tungsten and you get 7. Okay, so now we're looking at glucose. Glucose is a sugar, and it is made up of carbon, hydrogen, and oxygen, again, all nonmetals. So when it dissolves in water, it will stay together as 1 unit, so I will be 1. Okay, we're going to do our first calculation for one of those colligative properties. Here we're going to look at freezing point depression. So it says, what is the new freezing point of 3.1 liters of water with 490 grams of strontium chloride dissolved in it? So the equation we need is delta T equals minus 1.86 times the molality times that I. So first of all, that I involves strontium chloride. So we've got 1 strontium and 2 chlorides. So that's going to mean that I is 3. So now what we need is the molality. And you'll remember molality is moles divided by kilograms. And what we've been given is grams and liters. So if we look at this, strontium chloride has a molar mass of 158.5 grams per mole. So we need to convert that grams to moles. So we're going to divide. 490 divided by 158.5 gives us 3.09 moles of strontium chloride. And now we need to look at the number of kilograms. So if you look at that 3.1 liters of water, well, water has a density of 1. So 1 gram of water equals 1 milliliter of water. Okay. So 1,000 grams or 1 kilogram equals 1 liter. So 3.1 liters is going to equal 3.1 kilograms. So we can plug that into our formula here, and you'll notice that that number's on the bottom of the fraction in parentheses. So we plug these things in, and we find that the new freezing point of this system is negative 2.47 degrees Celsius. Now we're going to look at boiling point elevation. This is the exact same system, so we can use some of our numbers from the previous problem. But if we look at this, we can see that we want to know what temperature will this new this system right here boil. It's going to go up. So the change in temperature is 0.51 MI. So again, we're going to use I of 3 because we're still looking at strontium chloride. We need that number of moles of strontium chloride, so we're just going to use this number, 3.09 moles from the previous problem. And we can go ahead and plug that in to the formula, and we can see that we have 1.53 degrees Celsius. But we're not done yet, okay? We're not saying that the new boiling point of water is 1.53 degrees Celsius. Delta T means how much we've gone up, okay? So because it's a positive number, we've gone up. So what we have to remember here is we've got to add 100. So 1.53 plus 100 is 101.53 degrees Celsius. That is the new boiling point of water. This question says, what is the molality of a solution of lead 4 chloride that has a freezing point of negative 10 degrees Celsius? So what you'll notice here is that we're asking about that colligative property, that freezing point depression, but we're not asking for what the temperature is. We're asking for another variable in the equation. So what we're going to do is we're going to solve that equation for the molality, and you'll see we need delta T and we need I. Well, to get I, we look at lead 4 chloride. We've got one lead atom that has a plus 4 charge and 4 chloride ions with negative 1 charges. If we add all those together, we find that we have an I of 5. And if we plug this into our formula, we can see that this results in a solution with a molality of 1.08. Okay, here's our last question on the review for Chapter 14. How many ions does the mystery ionic compound have that raises the boiling point of water by 8 degrees Celsius and has a molality of 3.14 m? Okay, so what we're going to do is we're going to use that formula for boiling point elevation, but we're going to have to solve it for what? We're going to have to solve it for how many ions? So we're going to have to solve it for I. So when we do that, we can see here's the formula. I is delta T over 0.51 times the molality. So plug into this, and we see that it results in a number that is 5. Okay, you plug these into the calculator though, and you see it's 4.99. But because those ionic compounds have to result in whole numbers, it's got to be the nearest whole number. So we're going to round that to the nearest whole number and get 5 as our answer for I.